The formation of the first continents is a critical stage in the geological history of Earth, which gradually led to the creation of a stable continental crust, capable of supporting life. This process occurred over millions of years and had a significant impact on the formation of Earth and life on it. Here's an explanation of how the first continents came into existence. Formation of the first continental crust. After the initial formation of Earth, its surface was completely molten. Initially, all materials on the Earth's surface were in a molten state, gradually cooling down. As the Earth cooled, a thin, initial crust formed, primarily made of lighter and less dense materials like silica and aluminum. Due to their lower density compared to other materials on Earth, these substances rose to the surface and formed the first continental crusts. The initial crust was very fragile and temporary. Therefore, it was easily destroyed and reformed due to volcanic activity, meteorite impacts, and other geological processes. Over time, this initial crust evolved, eventually forming a more stable continental crust. Differences between oceanic and continental crust. The Earth's crust is generally divided into two types. Continental crust. This crust is lighter, thicker, and composed of rocks like granite. It is mainly found in land areas and is highly stable. The materials it is made of include silica, aluminum, and other light elements. Oceanic crust. The crust beneath the oceans is denser and thinner than the continental crust. It is primarily composed of rocks like basalt and has significant chemical differences from the continental crust. Over time, oceanic crust subducts beneath continental plates and is recycled back into the Earth. Evolution of the first continents, cratons. In the early periods of Earth's history, the first continents appeared as small, scattered islands on the surface. These islands, known as cratons, were older, stable parts of the continental crust that separated from other parts of the crust over millions of years and were recognized as the building blocks of the first continents. These cratons gradually merged together, leading to the formation of the first continents. Over time, these continents grew larger, with more rock material accumulating in them. This process increased the volume of land and gradually created larger landmasses on Earth's surface. Impact of volcanoes and tectonic activity. During this period, volcanoes and tectonic activity played a crucial role in the formation of continents. The movement of tectonic plates caused molten materials from inside the Earth to rise to the surface, increasing the surface temperature. These volcanic eruptions and associated activities added new rock material to the surface, contributing to the growth of the continents. Additionally, tectonic movements led to the breaking, folding, and collision of continents. These collisions resulted in the formation of mountain ranges and other geological features like valleys and faults. In fact, all these tectonic processes were responsible for the formation and stabilization of the first continents. Plate tectonics theory. The theory of plate tectonics is one of the most important and comprehensive theories in geology, explaining how the movement of Earth's large plates leads to the formation of continents, oceans, mountain ranges, and other geological features. Introduction to plate tectonics. Plate tectonics refers to the movement and shifting of large plates of the Earth's crust. These plates, which are sections of Earth's crust, float on the surface and are in constant motion. According to this theory, the Earth is composed of three main layers: inner core, made of iron and nickel, and has very high temperatures. Mantle, a layer between the core and crust, where materials are under high temperatures and pressures and can flow. Crust, the thinnest layer, consisting of both oceanic and continental crusts. Types of tectonic boundaries. The movement of tectonic plates can occur at three different types of boundaries. Convergent boundaries. At these boundaries, plates move toward each other and may collide. This collision can lead to the formation of mountain ranges, oceanic trenches, subduction zones. Divergent boundaries. At these boundaries, plates move apart, creating new rifts in Earth's surface. This movement is commonly seen along the ocean floor and results in the formation of oceanic crust. Transform boundaries. At these boundaries, plates move parallel to each other, often resulting in earthquakes and fault lines. Convection currents and their impact. Convection currents in the Earth's mantle, driven by heat and the flow. Divergent boundaries. At these boundaries, plates move apart, creating new rifts in Earth's surface. This movement is commonly seen along the ocean floor and results in the formation of oceanic crust. Transform boundaries. At these boundaries, plates move parallel to each other, often resulting in earthquakes and fault lines. Convection currents and their impact. Convection currents in the Earth's mantle, driven by heat and the flow of molten materials, play a key role in the movement of plates. These currents cause the Earth's plates to move toward each other or away from each other, and this process continues over time. Breaking of supercontinents. Supercontinents, like Pangaea, broke apart due to the movement of tectonic plates over time. This process not only led to the formation of new oceans and continents, but also caused significant climatic and geological changes. Effects of supercontinent breakup. The breakup of supercontinents helped create new oceans. For example, the breakup of Pangaea resulted in the formation of the Atlantic Ocean and opened new water pathways. Additionally, the separation of continents and their movement away from one another had significant impacts on climate changes. These changes contributed to the formation of new climates and ultimately aided in the evolution of various life forms. Tectonic plate movement and the formation of supercontinents shape Earth's surface, affecting climates and ecosystems. These ongoing processes will continue to impact the planet's future. Goodbye.